G'day guys. Alright, I hope you had fun yesterday with your little break. I thought you'd earned it after all this hard work you've been doing at home. But this is our second algebra lesson. We're looking today at something that's really important called like terms. Alright, so our learning intentions, today we're going to, learn what they are basically. We're going to be able to, at the end of the lesson, define like terms, what this means, identify them, and combine like terms using addition and subtraction. And none of that will make any sense to you right now because you don't even know what they are. All right, now to understand what a like term is in algebra, we first need to remember what terms are. So let's just flick over here for a moment. Let me write a random algebraic expression. I don't know, 6a squared plus 3b minus 7a cubed b to the power of 5 minus 6. Completely random. Okay, now that's an algebraic expression. What does the word term mean? Well, the terms, if you remember from our first algebra lesson, are the chunks, the groups of numbers multiplied by variables. So that there is a term, that is a term, that is a term, always including the sign that comes before the number, and that is a term, okay? Actually, I didn't mention this last lesson. That's a special kind of term called a constant, or a constant term, and that is a term that doesn't have a variable part. It's just a number. Anyway. All right, back to like terms. So, like terms, what are like terms? Terms that have exactly the same variable part are called like terms. Okay, so if a term and another term have different numbers, different coefficients, remember the number in front is called a coefficient, but the part that has variables in it is the same, then those two terms are called like terms. So for example, 3x and 5x are like terms. The number part is different, but the letter part, I shouldn't say the letter, I should use the correct vocab, the variable part is the same. And actually, when you have like terms, they can be added together and subtracted from one another. So it's possible to do 3x plus 5x and get 8x. Just in the same way, it's possible to say 3 pizzas plus 5 pizzas is 8 pizzas. They're the same sort of thing, so you can add them together and get an answer. If I said, what does 3 pizzas plus 5 burgers equal? You couldn't say 8 pizzas or 8 burgers or 8 pizzergers, or it just doesn't make sense. 3 pizzas plus 5 burgers is just 3 pizzas and 5 burgers. Okay, so if that was 3x plus 5y, I couldn't simplify that. I couldn't add them together. That would be the end of the road, okay? All right, so let's identify some like terms and some terms that are not like terms. Okay, 5ab and 2ac. The variable part is not the same in both of those, so they are not like terms. 11x squared and 5x squared are like terms. The number is different, the coefficient is different, that's fine, but the variable part of the term is the same, so they are like terms. 2xy and 5xyz are not like terms because the variable part here is different to the variable part here. Similar, but different. Okay, 3p cubed 3p cubed q to the power of 4 and minus 5p cubed q to the power of 4 are like terms, okay, because the part that has the variable in it, or variables, is the same, even though the numbers are different. And here's one I really want you to pay attention to. 6xy and 6yx are like terms. A lot of students think they are not like terms. The reason they are like terms is because the variable part is the same. Xy and yx are the same. They are equal because you have to remember that xy means x times y, and when it comes to multiplication in mathematics, order doesn't matter, does it? 2 times 3 is the same as 3 times 2. So xy is the same as yx, okay? So 6xy and 6yx are like terms. And it's just a coincidence that they both have a 6 there. 6xy and 2yx would also be like terms, okay? All right, now here's an important note. When you're trying to identify like terms, or just when you're trying to identify even just terms, you always have to consider the sign in front of the term, because that belongs to the term. Even my year 11s get this wrong, okay? So this is just a little bit of an important sidestep here. If we have this algebraic expression, all right, then these are the terms. 3g minus 2h, that minus belongs to the 2h term, plus 6. What sort of term is that, remember? Constant term. Minus 17g squared and minus 9gh. And actually, there are no like terms in there whatsoever. So that was just a little important note there, okay, guys? All right, let's do a couple of examples. We'll start off real basic. Simplify the expressions below. And there's a note. Like terms can be simplified by adding their coefficients. Okay, remember the coefficient is the number in front of the variable part. Unlike terms cannot be simplified. Full stop. All right, let's do question A. A plus A plus A plus A. Well, we can simplify that by adding their coefficients. And the coefficients are hidden. It's 1A plus 1A plus 1A plus 1A, isn't it? Which is 4A. Okay. Question B. 10x plus 10x plus 10y plus 20x plus 20y. All right, so now we have to start being careful and identifying our like terms. So I'm going to circle like terms in the same color. So here's a term. Are there any terms that will be a like term with 10x? Yes, because 20x has the same variable part. All right, I'm going to change colors because there are no other terms that would form a group of like terms with those two. Now we have plus 10y and plus 20y. They are like terms. Okay, so now when it comes to writing the answer, I can only add together terms that are like terms. All right, so I'm doing two separate additions here. I'm doing 10x plus 20x, which is 30x, and 10y plus 20y, which is 30y. Okay, nice and simple. Okay, question C. 2a plus 3b plus 5a minus 1a. All right, let's collect like terms. Well, let's identify like terms first. Here's our first term. I'm going to circle the term. What are the other terms with the same variable part? Well, the variable part of that term is just a lonely a. Plus 5a, that has the same variable part. And minus 1a has the same variable part. 3b, that's all by itself, isn't it? Plus 3b. All right, so when we collect like terms, we're going to do 2a plus, that plus sign there, 5a, which is 7a, and then minus, that minus sign there, 1a, which is 6a. And the lonely old plus 3b just comes downstairs and gets written next to the 6a, okay? All right, let's do some that are a little bit more complicated, all right? So 3a plus 5b minus 8a. I'm going to circle like terms in the same colour. So 3a and minus 8a are like terms. And plus 5b, that's on its own. Okay, now 3a minus 8a. See, if I drop that plus 5b out, if I just imagine it's not there, then I will have 3a minus 8a. What a lot of people do is 3a, this 3a, then they see this plus sign and they think it's 3a plus 8a. That's a mistake. That's why I'm circling things like this, okay? When we're collecting like terms, imagine all of the other circled terms that are not like terms drop out of the picture and the like terms just come together with their signs and everything, okay? So 3a minus 8a, well, 3 minus 8 is a negative number. It's minus 5. So minus 5a and plus 5b just comes downstairs, okay? All right, question B. We have, let me go back to orange, my favorite color. All right, I'm going to circle like terms. 7j squared. What else has a variable part that is j squared? Well, this does. Minus 3j squared. Okay, and that's it for j squared terms. What about terms with a variable part that's just k? Well, we have plus 5k and plus 1k. And then we have a constant term all by itself, minus 3. If there was another constant term, maybe at the end, you know, a minus 2, then those constant terms would be like terms, and they would combine together. All right, so let's collect like terms. 7j squared minus 3j squared. 7 minus 3 is 4, so I get 4j squared. Now I'm going to do the k's. 1k plus 5k is 6k, positive, so plus 6k. And the minus 3 just comes downstairs. All right, moving on. Question C. 3xy minus 5y plus 7xy minus 2y. Circle my like terms. What terms have an xy part? That, 3xy and plus 7xy. And the remaining terms are like terms because they both have a variable part y. Minus 5y minus 2y. So now I can collect like terms. When I say collect like terms, it just means add or subtract them add them together or subtract them from one another. All right, 3xy plus 7xy is 10xy. Easy. Minus 5y minus 2 more y brings me back to minus 7y. So 10xy minus 7y. And one more. All right. So what do we got here? C plus d minus 3c plus 5d squared plus 2c. All right, the first thing I see is 1c. So does anything else have just c as the variable part? Yes. We have minus 3c here, and positive 2c here. All right. So that's it for those terms. Do we have any other like terms? No. Some people might think, yes, plus d and plus 5d squared, they have the same variable part, d. They both have d's, but it's not exactly the same, so they're not like terms. 1d would be a like term with 5d. 1d is not a like term with 5d squared. A d squared is a different thing from a d. So those are all on their lonesome, so they get their own colour. Okie dokie. So, collect like terms. 1c minus 3c. Well, 1 minus 3 is minus 2, so I'm at negative 2c. Negative 2c plus 2c, that brings me up to 0c. So I don't write any c's. It'd be silly to write 0c because I don't have any c's. I've got 0 of them. So the c's have all cancelled out. And the plus d and the plus 5d squared, they just come downstairs and sit there next to one another. D plus 5d squared is the answer. All right, guys, I think that is enough. I'm going to set you an exercise. Have a look at the home learning schedule to see what questions to do. Good luck. Hit me up with any questions you might have, and I'll see you next time.